Don't you fear not being around?
I fear living a life where I could have accomplished something and didn't.
What is the chance of an asteroid smacking into us?
The good thing about
like the movies.
The good thing about this is that the bigger, the badder the asteroid, the farther away we will likely discover it before it does any damage.
Why do you not fear that AI can become genuinely sentient and start making decisions completely on its own?
Do you think there's such a thing as a soul?
Who do you think is the most extraordinary scientific mind that that humanity has produced?
There is no contest. Isaac Newton.
Explain why.
He, working alone, discovers the laws of motion. Then he discovers the law of gravity, universal law of gravitation. Oh, and then someone asks, why do your planets orbit in this shape, ellipses, ovals, rather than perfect circle? They say, I don't know, I'll get back to you. And he goes home, and he comes back, I finally have my answer. And they say, well, Isaac, how did you do that? Well, I had to invent integral and differential calculus to answer that question. He does all of this. Then he turns 26. What does it mean to be dead? Okay, it used to be, did you fog a mirror that was held up in front of you while you were laying there on your bed, all right? And if you didn't fog the mirror, you were judged to be dead. They would put you in a coffin, and in some parts, it is told, there's a string that they put into the coffin as they buried you, and they put it over a tree branch and connected to a bell. If you woke up, you would pull the string, and that's where you get the term dead ringer, okay? You would pull the string, and you come rescue me because you buried a living person, okay? There was an incident in Pasadena, California. I was there. I'm in there, I order hot chocolate, and I ordered it with whipped cream, of course, right? And it comes to the table, and there's no whipped cream. And I said, I ordered this with whipped cream, and they said, oh, we put it on. And I said, well, where is it? Oh, he said, it's sunk to the bottom. Either the laws of physics that apply everywhere in the universe are suspended in your coffee shop, or you didn't put whipped cream on my hot cocoa. He intended to prove me wrong. Whoa. So he went into the kitchen, brought out the whipped cream, scooped it up, popped it in my hot cocoa, and it bobbed once and floated atop. Of course, whipped cream has to float.
Elon Musk is of a view that we need to have our life taken to other planets. And he also says that we are in desperate need of more people, not fewer people on the planet. What do you think of those two things?
It's a matter of, can we sustain a population with the resources we have and our access to it? Some projections show that we'll level off at about 10 billion people on Earth, and I find those projections convincing, unless we double our life expectancy. If we do, and we run out of space, we need another planet. So I kind of like other planets because I'm an astrophysicist.
Where would you most like to live?
There's no choice in the matter. It would have to be Mars.
There's no other option?
No, no.
Could there ever be?
You'd have to go to Venus and try to have it not be 900 degrees Fahrenheit, okay? And I did the calculation. You can cook a 16-inch pizza on the windowsill in 3 seconds, okay? You would vaporize too, but it's fast, in the atmosphere. Black holes are not quite what you think they are. They're not giant sucking machines.
No, they're not.
If the sun became a black hole, Earth would still go around in orbit, like it would be dark and cold.
Right.
But orbitally, it would make no difference to us. So just because it's a black hole doesn't mean it's reaching out in places it didn't previously reach out to eat you.
So are you saying that anything in orbit around a supermassive star that collapses under its own self and becomes a black hole, if it's already in that orbit, then it will not cross the event horizon created by that black hole and just continue to be in that same orbit?
Unless the black hole eats by some other means, then the black hole gets bigger. If you fed the black hole top and bottom, now the black hole will grow, its gravity will increase, and it could increase to such a point where your speed in orbit is insufficient to maintain your orbit. Then your orbit decays and you fall in. That could happen. The objects had to have been headed towards the black hole to get eaten.
To begin with.
Columbus crosses the Atlantic, makes contact with humans. This is the first time that has happened in 10,000 years. We have rejoined two branches of the human species. We are now one common genetic group. And that genetic crossbreeding now continues to this day. We fly to any corner of the world and mate, okay? And the mating already began immediately. Yes, there were diseases that Columbus brought to North America, much written about that. Less written is that he brought syphilis back to Europe. First cases of syphilis of 1492.
Whoa.
And another thing, you mentioned the God of the gaps. In a free society, a free pluralistic society, where the freedom of the expression of religion is constitutionally protected, which is a fundamental part of why America was so attractive to immigrants from around the world whose religious differences were not being supported in their hometown. I will never be one to tell you what you should believe or what you should not believe. What I will say is that if you want to say that where we don't understand things, that's where God rests, that's where God operates, the God of the gaps argument, because I get asked that all the time. What was around before the universe? I don't know. Must have been something, God. So they got to stick in God where we're not there yet. And I just say, we got top people working on that. It's a current frontier. We're not there yet. And given the history of the moving frontier, where people had previously said, well, God must be operating, we're long past that. Those explanations have come, and so there's no compelling reason to say God did it and then sort of give up and go on to the next problem.
For 10, what is your favorite fact about the universe? Of the unbelievably large number of facts you must have ascertained along with your scientist colleagues, what's the number one fact that you love most?
I am astonished every day I wake up that the universe is knowable. Even on the small scales that the nuts that we've cracked for it, that it's knowable at all, that we are just, billion-year-old carbon, as Joni Mitchell puts in her song Woodstock. We can rise to consciousness and pose questions about our origin. It's been suggested that we are a way for the universe to know itself. But the fact that the universe is knowable at all, to me, is stupefying. Because who said it had to be that way? That we measure laws on Earth and they are the same as they are in the heavens. Right now, AI is basically everywhere. There's no tech company that isn't fully exploiting the value of AI to their business model. In my field, which is not even a corporate entity, it's just science. In my field, astrophysics, we've been using AI at any possible point that it could advance us. We use it, and we've been using it for decades.
Why aren't you terrified of it? Because you're very positive about AI.
Okay, there are people who will read you the riot act about the future of AI, and many of them are deep in the field. So I'm not here to undo their concerns. All I will tell you is, AI in its sort of restricted form, where I have a task, I don't want to do it. Let a machine do it, and let's teach it and have it machine learn what it is I need it to do and have it do it. That's kind of how AI has manifested in society.
Why do you not fear that AI can become genuinely sentient and start making decisions completely on its own?
Yeah, it depends. You can make a decision, but how much power are you going to grant it?
Do you think there's such a thing as a soul?
So let's go back 120 years.
Okay.
The discovery of X-rays. Religious people of the day said, we can see into the body. Let's X-ray people while they're on their deathbed. And as they die, let's see if we can see something rising up out of the body. Of course, they didn't see anything. Everything you are derives from electrochemical synapses running in your brain. What is it that was there when they were alive? Well, we have some evidence for this. The neurosynapses of your brain. When I can't even talk to you, you don't even know where you are or what you're doing or what's happening to you. You have no awareness.
so I remain unconvinced that the soul is something other than a word we give to your neurosynaptic thoughts that enable you to say, I am an individual and I have a consciousness. Last fun fact about the sun.
Okay.
All right. If we're about 8,000 miles across,
Right.
if you look up the diameter of the sun, it'll give you something like 864,000 miles, something like that.
Jesus.
Okay. All right. So now let's round that down just so the numbers come out fun. Call it 800,000 miles
So
across.
it's 100 times bigger.
It's 100 times
100 times.
100 times across.
Across.
So you can take Earth
100.
and position it 100 times back to back, belly to belly, and you'll span the width of the sun.
Wow.
Okay, 100 times. Now, by the way, that's about the size of sunspots. So the sun has blemishes larger than Earth.
Than the Earth.
Just so you know.
Jeez.
All right. So now, if it's 100 times across, that means it's also 100 times deep.
Deep. Yeah.
It would be 100 times top to bottom. So how many Earths could fit
Can you
into
just
a hollow
pour
sun?
into the
Pour
sun?
into the sun.
That's 100 times 100 times 100.
Give me what that number is. The sun were hollow. You could
You
pour a million Earths into it
Wow.
and still have room left over.
One of its planets can't spin because of the gravity of its star. Now, why doesn't that happen to Mercury, being as it's so close to the sun?
So if you have a planet or anything that's orbiting close to something else that has strong gravity, tidal forces will slow down its rotation so that it'll only show one face to you. One face to you. And so when that happens, it's called being tidally locked. We have locked the moon. There's a far side of the moon, there's a near side of the moon. Pluto and its moon Charon are close to one another. They have double tidally locked. They show the same face to one another as they move around. Mercury does not, and it's because Mercury has a resonance, okay? Mercury feels the gravity of other objects in the solar system, in particular Venus. And when you feel another source of gravity in addition to that of the sun does not succeed in totally tidally locking the planet.
You mentioned asteroid. What is the chance of an asteroid smacking into us?
The good thing about
Like the movies.
The good thing about this is that the bigger, the badder the asteroid, the farther away we will likely discover it before it does any damage.
But isn't it the less likely that we can protect ourselves, the bigger it is?
No, well, if we discover an asteroid that might hit us in 150 years, plenty of time to do something about it, given the rate of technology and the ingenuity
How do
that
you
we have as a
stop
species.
a gigantic existential
you don't.
asteroid?
It's not a Bruce Willis bomb thing.
So what do you do?
Yeah, you go in and you deflect it.
How?
Oh, by any shove on it that's sideways?
Well, you're president of the United States.
No, well, yeah,
Right?
okay.
There's a massive asteroid. It's going to crash into the world.
Yes,
and it's going to cause the kind of thing we saw with the Bruce Willis movie.
We have engineering plans for deflecting asteroids.
What if Earth were the size of the schoolroom globe? So I have here Earth
A schoolroom globe.
as a schoolroom globe.
All right.
So we can ask the question, if this were the size of the Earth, how far away would familiar things be? This is about the actual size of the moon. I would ask you, place this at the distance you think it should be from Earth, based on everything you know. go
So
ahead.
that's the size of the Earth.
Yeah,
This is the size
Yeah,
of the
so where would you put the moon in its orbit around Earth?
Yeah.
Right there? Okay, Chuck?
So maybe about here.
You're both wrong.
Okay.
Okay. On this scale, the moon would be 30 feet away
Holy
in the next room. So now what about planet Mars?
Mars.
So where would I put Mars? Mars is smaller than this, by the
Yes.
way. Mars is between the size of the Earth
Earth.
and the moon.
Right.
Okay. This would be about a mile away.
What do you make of AI? What do you think?
I love it.
Yeah.
I love it, but it's by the way, it's been here for a while. It really spooked people when it started writing your term paper and composing your painting and your set design. All right, that the whole other category of people got spooked by that. Meanwhile, AI has been harnessed and being fully used in my field and in most of the physical sciences It's doing work. If you can do the work, and I can go to the Bahamas, let it do the work. We have telescopes coming online that could not exist without the intervention of AI to access the data, reduce the data, analyze the data, make a decision about whether it should go back to the thing that it just observed, because that was weird compared to the last time it was observed. This is the Vera Rubin telescope that I'm literally describing now. And so we're living with it. What it means is it'll have to up the game of people who say they are creative.
Don't you fear not being around?
I fear living a life where I could have accomplished something and didn't. That's what I fear. I don't fear death.
You don't fear the unknown?
I love the unknown. I love the, you know what I want on my tombstone? My sister has this in her notes, because in case I can't tell anyone after I die. On my tombstone, a quote from Horace Mann, great educator. Be ashamed to die until you have scored some victory for humanity.
Millennials are not, or only 64% are convinced that the world is a ball. The world is a circle, that the world is a spheroid? Is that what it's called? Oblique?
These differences in measurements are so small that if you found it on the ground, you would say this is a perfect sphere.
Right.
Let me tell you how good a sphere it is.
Right.
All right, you ever see the schoolroom globes, the geographic globes? And you rub your finger over Nepal and you get the Himalayas. Yeah, and you get the Rockies. And so, that is a gross exaggeration of reality.
Yes.
Do you realize if you took Earth with all of its mountains, valleys, and hills and shrunk it down to the size of a cue ball, it would be smoother than any cue ball ever machined.
Really?
Yes.
You've seen that thing on Jupiter, that storm that never quits? The big red thing, the big...
Yeah, we call it the red spot on Jupiter. We call it Jupiter's red spot.
Okay.
Yeah.
Isn't it suspicious to you that a storm there could go on for 350 years without a break, and we never have storms that go on for 350 years without a break? We don't even have storms that go on for like 6 weeks without a break.
So what is Jupiter? It's 100 times bigger than Earth. More than that, 10, 1,000 times bigger than Earth. It's mostly gas. And it rotates once in about 10 hours. You want to talk about ferocious Coriolis forces? We have storms that last weeks here. Hurricanes that pick up and they go weeks on this little speck we call Earth that has this much atmosphere on it. Go to a planet that rotates twice as fast, is 10 times as wide, 1,000 times the volume, and is mostly gas, and you're complaining that it lasted 300 years? I'm going to tell you some of the ways the universe will end. As you may know, we are currently expanding.
Yes.
All right.
That's right. Growth, damn it.
And as we expand, the universe gets thinner and thinner, less and less dense.
If you're not growing, you're dying.
Well, consider, how do you make a star? We have a gas cloud and it collapses
right,
to make a new object.
Right.
But if things continue to expand, then there's an interesting sequence of events. First, there are galaxies that have already used up all their gas.
Okay.
They have these elliptical shapes. We call them elliptical galaxies.
Oh.
They don't have any gas, but they have stars that will live 1 trillion years.
Wow.
After 1 trillion years, those stars start dimming out one by one. So it's not just an expansion that'll continue forever.
Right.
It's an expansion that will accelerate. So first, yes, all the galaxies will accelerate beyond your horizon. That'll happen. We got that in the first one, okay? But here's what the difference is. If that acceleration goes unchecked,
right,
then it'll start ripping apart things that would otherwise retain their integrity from their gravity. We call it the Big Rip. And they do the calculations, that'll happen in 10 to the 22 years. It'll happen before the black holes evaporate.
Oh, I'm very worried.
Third and last,
okay,
there's no data to support this next idea.
Okay.
There's nothing to tell us that we will ever recollapse.
Okay.
Because our expansion speed is greater than anything the collective gravity of all galaxies could possibly muster.
Okay.
To try to bring it back.
Right.
All right. So, but if something gets discovered that will slow down the expansion and then have us recollapse, then everything will happen sort of in reverse. The universe will get hotter and hotter and hotter.
Right.
Instead of cooler and cooler. Things will get more and more concentrated. And ultimately, we'd all come back to the same point.
Same singularity.
And they call that the big crunch.